This presentation is brought to you by the MFOA.
Good afternoon and welcome to MFOA's Municipal Finance Internship Program's webinar, Stop Flushing Your Money Away, Best Practices for Reducing Water Loss. And now I'd like to introduce your presenter for the day. Kevin Yarskovich is participating in MFOA's Municipal Finance Internship Program at the town of Newmarket. He is a graduate of the Honors Economics, Politics and Philosophy program at Western University. He has worked on a variety of projects for the town, including proposing the 2015 water and wastewater rates and acting as a contributor and contributing editor for the town's asset management plan. Beyond work related to this seminar, Kevin has worked on the projects related to assessment growth, projections, bilateral funding agreements, senior financial services, funding for parkland dedication, and storm water management rates. Thank you very much for joining us today. So Kevin, please take it away.
Thank you, Eunice, for the introduction. So, as Eunice said, my name is Kevin Yarskovich, and the title of my presentation today is Stop Flushing Your Money Away, Best Practices for Reducing Water Loss. Here's our agenda. The introduction for today sets the definitions for our webinar. The major points of the presentation are divided into two parts. The first part will discuss why we need a paradigm shift in how we build our water distribution systems. The second part will discuss the metrics that you need to know to prevent water loss by your water meters in the most efficient way possible. The conclusion will set out what key performance indicators you can add to your asset management plan to keep track of your progress on what you will learn today. So before we get into the meat of the presentation, we should establish some definitions so everyone understands what I'm talking about when I use these terms. Non-revenue water is all the water that utilities make safe to drink but do not make any money off of by selling it. Real losses are one subset of non-revenue water where the water is lost through leaks and breaks of your water pipes. Apparent losses are another subset of non-revenue water. The water is purposefully used but does not provide any revenue for the utility. Flushing is the act of releasing water from the distribution system to clean the pipes and replenish the pipes with fresh water. And this will be talked quite a bit about in our presentation, and I have a picture of flushing in the slide here. With the definitions established, this brings us to the first part of the webinar, rethinking the way we build water infrastructure. The thesis of this part is that municipalities should be repairing and recalibrating their water distribution system, not necessarily expanding it. I want to address the apparent bias that municipalities have to go big or go home with respect to capital projects. Now, I observed this bias in many ways, but one of the most telling ways was when I attended a webinar on key performance indexes. At this webinar, one of the slides showed a table like this one. The table is meant to grade how much excess capacity a road has at a given time. As you can see, the more excess capacity you provide, the better mark you can give yourself. There is no such thing as too much capacity in this grading scheme. And I think this comes from the idea that, sure, we might not need all that capacity today, but we might need it eventually. The thing is, that eventually might not come as soon as you think, or it might not come at all. To inform this webinar, I looked at water consumption data in Newmarket and abroad to see where water consumption levels were going. The quote to set the tone of what I'm about to say is by John Maynard Keynes. He said, "When the facts change, I change my mind. What do you do, sir?" My goal in this first part is to change your mind on how to build water infrastructure based on the changing facts. So let's get into the facts, shall we? Here is a chart of our water consumption per capita. As you can see, consumption trends are going down. Between 2003 and 2013, consumption per capita fell by 30%. What I found, despite Newmarket's 20% population growth over the 10-year period, total water consumption dropped by 15%. What I'd wondered is this a fluke? Is this unique to Newmarket? So I looked at other municipalities in the York region. Pulling from financial information returns, I found that despite the region's population growth rate being twice the provincial average, the total amount of water consumption in these municipalities only grew by 4% over 5 years. Then I started looking at other municipalities in Ontario, and they show a very similar trend that consumption per capita, even total consumption, is going down. Can we expect this trend to continue? I argue yes. The trend is decreasing. The trend of decreasing consumption is long-term. And I highlight 5 reasons for why that is. They are adoption of new technology, water prices, intensification, the new economy, and building standards. So the first idea is that Canadians are adopting water-efficient technology to help themselves save water without changing their lifestyle too much. Low-flow technology went through its growing pains in the 1990s and 2000s when shows like Seinfeld and King of the Hill joked that low-flow shower heads cause bad hair. Now, over 60% of households have low-flow shower heads. Can you tell looking around your office what shower heads people have at home? The second point is basic economics. As prices rise, consumption falls. According to a major intermunicipal study conducted by BMA Consulting, asset replacement funds across Ontario are funded well below 100%. Municipalities are now presumably becoming more aware of this due to the introduction of asset management plans. This means that we have to play catch up with our finances, and this means that water prices will continue to rise well above inflation. The rising prices will create a market for more water-efficient technologies, like gray water recycling, stormwater retention, and other low-flow technologies that are yet to be profitable. The third idea is intensification. Some communities are intensifying in pursuit of having a better urban lifestyle, while others are being pushed by the province to intensify through Places to Grow Act and/or the Green Belt. Either way, communities are intensifying, meaning less water, less lawns to water, and pools to fill per capita. And in case you're curious, the slide here is showing what Davis Drive in Newmarket looks like now and what it's supposed to look like in 2051. Big change. The fourth point is that Ontario manufacturing jobs are declining and are unlikely to make a significant comeback. Between 2004 and 2013, manufacturing jobs declined by 32%. It goes without saying that most manufacturing customers tend to use a lot of water. And I have a picture here of a car assembly line because The Economist magazine recently predicted that the automotive industry will be gone from Canada between 2030 and 2040. Their reasoning was the lack in investment of new capital and increased globalization will cause this demise. And this is an automotive industry leaving the country isn't unheard of. It already left Australia. And many Ontarian economists are saying to invest in future industries, not where the puck has been, but where the puck is going. So education, finance, technology is likely where the jobs are going to be in the future. The last point is that the current building code includes water conservation as an objective, sets out requirements for water efficiency of fixtures, and may increase standards in the future. So every new house that's built is going to have water efficient technology by default. So by now I hope you are convinced that consumption trends will continue to decrease in the future, and I want to forewarn you of the negative impacts of not taking consumption trends into account. The most simple impact of overestimating water consumption is that you won't get the revenue that you have been expecting in your 6-year water financial plan. Newmarket was hit a few years in a row due to low-level water consumption, and we will be updating our 6-year water plan to not be so optimistic about our revenue. More interestingly, though, as Newmarket's water consumption went down, our non-revenue water doubled over the last 10 years. Over the next few slides, I'll explain why this might be. One idea of why our non-revenue water is rising is because while our demand for water is decreasing, we are expanding our capacity to deliver water. I have this image here to illustrate that the water supply is exceeding demand. When supply exceeds demand, water slows down in the pipes and the water begins to age in it. When the water gets old, it becomes a risk to human health. To ensure that our water stays young and safe, we have to flush the water from our system to maintain the quality more than we otherwise would. The U.S. Environmental Protection Agency identified 11 different incidents that occur when water stays in the pipes too long. Those with an asterisk would cause direct negative impact on your health if consumed. While a funky taste or odor caused by old water poses no threat to your customers will complain about it. There's a very simple way to reduce water age. That is to increase the fixed rate and lower the variable rate. This rate structure makes water consumption cheaper by volume, resulting in more people consuming more water. Customers on a fixed rate, on average, consume 75% more water than those on a full variable rate. What's wrong with this approach is that it creates an unnecessary tug-of-war within a municipality where some are actively trying to increase consumption while others are actively trying to decrease consumption. The alternative to infighting will be discussed on the next slide. Oh, sorry, here's a slide here where it shows the difference between the different sizes of municipalities. The bigger the municipality, the lower the water consumption is per capita on average, and the more metering there is, the lower the consumption. So the second option. From my research, I have found that many different departments and business units within a municipality that need to know and project water consumption per capita have different numbers. The water financial plan, the water master plan, the water conservation plan, the service allocation strategy, and the engineering standard should all have the same water consumption projections. It makes sense that they all agree with each other because they're all servicing the same people. For example, one problem could be if your engineering standard calls for pipes to be built to service a capacity of 400 liters per person per day, while your service allocation assumes that new residents will only consume 300 liters per day. For every new household that moves in, you're overbuilding capacity by 33%. This would cause a hindrance to your growth due to having excess capacity not tapped into, and increase the water age due to overbuilding capacity. To fix this, I would recommend gathering stakeholders from each group that establishes standards and compare notes. Maybe everyone had their own method of projecting water demand and they could be right by themselves. Financial planners, for example, may use the process of forecasting using current trends and assuming that no intervention is made to change that trend, while water conservation planners may use the process of backcasting, where future consumption is set as a goal and they actively intervene in the current trend to reach that goal. So in one municipality, I've learned that water consumption has decreased to the delight of conservationists, but to the demise of financial officers. It's a shame. This potentially good news story didn't have to be that way if they effectively communicated and took into consideration each other's intentions to begin with. So in Newmarket, we started these conversations. One of the products of the conversation so far is that in our asset management plan, we included this chart to identify a theoretical basis for triggers to replace our assets. Our plan mentions that infrastructure can be downsized to reflect the required capacity and reduce waste due to flushing. And let me be clear here. What this table is not saying is that we will dig up a road and replace the pipes just to downsize it to better reflect water demand. What it is saying, though, is that if a road is in poor condition and needs replacing and the pipes itself is getting old too, the fact that the pipe is too large or too small will be considered and may bump up the priority of the project. And what does this mean in practice? So Newmarket is divided into three pressure zones: the west, the central, and the east. On the east side, it's relatively undeveloped, and we have a new subdivision going in. So it's clear that we'll need to expand our capacity along there. In the center area, in the downtown, it's mostly all built up area. And there's not much room for growth. So while consumption per capita is going down and not too much growth is going in, that means that we'll need to keep an eye. It's likely that not much new capacity will be needed. While on the west side of the municipality, there is going to be growth. At the same time, water consumption is going down. So this means that there's two drivers, one that's pushing consumption up and one that's pushing consumption down. So we have one district that we do not know where the consumption trend is going to go, either up or down, another district where it's likely to go down, and another district where it's likely to go up. So we need to keep an eye on this and calibrate it, and not necessarily expand the system, just recalibrating it. So this is a concluding slide of the first part of the webinar, and I want to bring us back to the thesis: repairs and recalibration, not necessarily expansion. Water consumption is decreasing, and overbuilding causes excess water to be flushed. Because water consumption isn't increasing as quickly as people originally thought, maybe hold off on expanding a pipe, building a new reservoir, pumping station, or treatment plant. Each local utility may have its own solution to solving this emerging problem. Just don't go with the flow. So now we're getting into part two of the presentation. Part two is about collecting data. This data is required to make informed decisions to help you save water and money. To reduce non-revenue water, you have to have a good understanding of what is causing non-revenue water. I have read stories where intuition has failed water distribution utilities in the past, where great financial resources were invested in order to address one water loss issue with little results. That's why I encourage you to meter and estimate all the sources of non-revenue water feasible. Then set a target for where you would like to be. You might want to say zero non-revenue water is the target, but that would be impossible and extremely expensive pursuit. Discuss with your colleagues what level of non-revenue water might be achievable in the next decade. As a benchmark, in Canada, the average percent of water that is lost through flushing and leaks was 13.3%. This percent does not account for unbilled consumption. No data was found estimating the average total percent of non-revenue water. Non-revenue water target setting has been done in other jurisdictions. For example, California sets non-revenue target to be 10%. To learn more about how to measure non-revenue water, Chapter 2 of Manual 36 of the American Water Works Association is a great resource. Once you have this data, you can compare your total non-revenue water to your desired non-revenue water goal. In collecting the data, your goal should be to fill these boxes as much as possible with flow volumes so that you can identify the greatest cause of non-revenue water. So this table has a bunch of different categories. So there's the water meter inaccuracy, which we'll be talking about soon, and then there's flushing, maintenance, flow testing, and the more detailed you can get this information, the better you can address your non-revenue water problem. So it goes without saying that meters are an essential part of tracking water consumption. However, I have found that many municipalities do not pay as much attention to them as they should. If meters are neglected and not properly maintained, they begin to slow down. This means they begin to under-register and you lose potential revenue. To get started on taking better care of your meters, you need to know a few basic things. The 3 key bits of information you need to know about your meters is quantity and customer type, age, and accuracy degradation. So when I was working on the water pricing policy, I collected the data for our meters from our billing database and graphed it out like this. And the meters do look a little bit like a suspension bridge, but it doesn't have anything to do with other than that's when growth happened. The big spike at the beginning in 1988 was caused because that's when our paper copy of our database went to an electronic copy, and they were all inputted to be installed on a particular date in 1988. And once the age of our meters was determined, the town of Newmarket swiftly sought and received council approval to implement advanced metering infrastructure and replace old meters with new smart meters. The advanced metering infrastructure will help Newmarket detect leaks in our pipes and help Newmarket provide better customer service and better consumption data analysis. Through wear and tear, we know that accuracy of meters degrade, and on the next slide I'll show you ways you can find out how fast. There's 2 ways of doing this. The first way is to go by your supplier's warranty. It's quick and it's easy, but it's not necessarily accurate to specific circumstances. Given the age of our meters, we use this option to justify replacing our meters. When the age of our meters was determined, the business case for implementing advanced metering infrastructure was already in the works. It was perceived that the benefits to Newmarket of implementing the infrastructure already outweighed the cost of considering the benefits of the increased accuracy. The increased accuracy was just the cherry on top of this project. Now, to fine-tune your meter replacement program, I recommend doing random testing. Randomly selecting and testing about 40 meters per year can give you a great sense of how your meters are performing. You can learn how your meters react to the water you distribute, how well your meters stand to your supplier's claims, which meters and companies perform best over time, have your meters fixed while they're still under warranty, how meters slow based on other factors, and age is proving to be not a very good indicator. Actually, water flow creates much more wear and tear than actual age. And so you don't really know how well your meters are performing until you test it. Now, some municipalities do testing programs, but it's on a reactionary basis where they only test it when customers complain about the measurement. But customers aren't likely to complain about it measuring too low. They're complaining about it measuring too high. So you can't get a good idea unless you're randomly testing your meters. So once you know more about meters, you can determine the optimal replacement rate and how much you can profit from actually replacing at the optimal replacement rate. So the 2 main drivers in this model of calculating optimal replacement rate are replacement cost and lost revenue. So the red line here with the squares is the replacement cost. The less frequently you replace it, there's an exponential decrease of the cost. But at the same time, the less you replace it, there's a linear increase of your revenue loss water. So with this graph in mind, let's go through an Excel sheet and see how it works in practice. So there are some variables that you need to input into the model in order for it to calculate your optimal replacement rate. So I'll put in Newmarket statistics. So build average household consumption. In Newmarket, it's 200 cubic meters per household. And the price that we charge per cubic meter to our customers is $3.15 per cubic meter. And then the price that it costs us to treat the water is $1.52 per cubic meter. The degradation rate, the supplier's warranty said it degraded at 0.5% a year. The replacement cost, talking to our operations team, they estimated it would cost $250 per meter to replace. Number of meters, we have 25,000 meters in our municipality. Average life of meters online right now, our current average life is 16. And residual consumption, we'll just assume that this is 100% right now. So then what happens here is it inputs all the numbers into the model at each replacement rate. So there's 2, 3, and this is how much revenue you'll lose, and this is your replacement cost, and then it graphs it out right here, just like you saw on the PowerPoint presentation. And then if you go here, it tells you your current replacement rate, which is every 32 years you replace your meters, and this is how much you should be replacing your meters. And then it tells you your current revenue loss and then your optimal revenue loss, your current replacement costs, and then your optimal replacement cost. And then, so according to this model, if Newmarket switched from going from 32 years replacement rate to 12 years, we'd profit $500,000. Now these numbers are easy to play with. So let's just say you think that the water meters don't degrade as quickly as that. They actually degrade 0.3% a year. Then you can go here and then you can see what happens. Then the optimal replacement rate isn't 12 years anymore, it's 16 years. And then the maximum profit is $200,000 instead. In this model also, so this thing here, this assumes that if you start measuring consumption, that customers will be completely unaffected by the price, because more consumption is going to be measured, so that means their bill is going to go up. Now, if you think that your customers are going to be price sensitive and they're only going to consume 70% of what they were, 70% of the increase of billing, then that's what you would put. And then you can see how much, now that you're measuring more and you're billing more, people are curbing their consumption a little bit, so then you can see the equivalent of how many households of water saving. So by inputting a new meter, you're saving money, and you're also reducing water consumption. So that's the model. So key takeaways to reduce water loss. Determine the cause of your non-revenue water and measure and estimate it. Learn more about your meters and about how they perform in your water distribution system, and use the model provided to calculate the optimal replacement rate and execute a replacement strategy. Now I'll tell you how you can incorporate what you learned in your asset management plan. From my discussions with Newmarket's operations staff and engineering staff, there's a trade-off of building capacity. If your water distribution capacity is too large, then you risk having a greater number of adverse water quality incidents, meaning the water quality is not addressed. If the water quality is not addressed, it may become a risk to human health. If your capacity is too small, it becomes more difficult to achieve the desired level of water pressure, which means slower water flows when you turn on the tap. So to quantify and balance these two issues, I've pulled some key performance indicators Newmarket has to reflect the trade-off. The first two KPIs reflect water quality. Tracking adverse water quality gives a sense of the water quality, and the boil water advisory days should always be 0, but it's a good indicator to have. And on the water pressure side, we have the average pressure of water in our system, and also the percent of fire hydrant flows that meet the standard, and that one again should always be 100% of the time. The capacity and efficiency operational indicators relate more to the second part of this webinar. Quantifying non-revenue water and average age and accuracy helps keep an eye on how your assets are performing. Having operational indicators will help keep track on maintaining your assets, and the hope here is that what gets measured gets managed. And that concludes this part of the presentation, and now I'm open for questions.
So the first question is that we have, who developed the model that you've just shown, and was it validated by anyone?
So I developed the model. As said in the introduction, I graduated from Western with an honors economics degree, and in economics, this is the type of work that we are trained to do, is to find optimal situations and maximize profit. So this is something that, yeah, I've been doing quite a bit. And then it's been validated by my colleague who's a senior financial analyst here, and yeah, he's great with numbers. He has an MBA, and yeah, he looked through it and he thought it was sound.
Great, thank you very much. The next question that we have is, what is the estimated useful lives that Newmarket uses for their water mains in their asset management plan?
We use 50 years in our asset management plan.
Great, thank you. Next question is, how is non-revenue water calculated?
Non-revenue water is all the water that enters into the distribution system that is not does not collect any revenue. So you have your total water treated, and then subtract that by the amount of water that you collect revenue on, and then you have your non-revenue water amount, and then divide that by your total water treated to get your non-revenue water percentage.
Awesome, thank you. Next question is, how do you do your random testing of water meters?
So the random testing, yeah, so you do that. You select them at random. You don't choose it based on any characteristics. Don't just pick the old ones. Don't pick and choose. Just select them randomly. And then what you do is you take the meter and you test it through 3 different flow volumes, one low, one medium, and one high. And then you see how they perform at each level, because there's things that can go wrong at different levels. And then to find the average flow accuracy, you do a weighted average with that. So you would weight the low and high volumes maybe at 20% each, and then the rest of the 60% for the medium volume, because that's the one that you will get the most flow at, and that's the one that's most important to have accurate flow level for.
Okay, thank you. Next question is kind of based off of that as well. How do you select the random meters? Do you remove meters or wait for the demolition to change out?
How to select the, sorry, can you say that question?
Yeah, how do you select the random meters? Do you remove meters or wait for demolition or change out?
In terms of how to select it randomly, I would encourage you to talk to your IT. I don't know that offhand if there could be a random number generation software that could match up meters to that for you. And then it's best to do your meter testing on site, because there are some things that change, the environmental conditions or just the way that the meter is hooked up, versus if you bring it into a lab and test it. So it's best to do it on site. If your municipality doesn't have the capacity to do it, to hire a contractor to do it for you, and then that way you get the truest, most accurate measurement, because I've heard stories of where people, the meter performs poorly when it's installed, but in the lab it works just fine. So things change when you move the meter, so it's best to do it on site.
Great, thank you so much. So that concludes our Q&A session. So thank you, Kevin, for sharing such valuable information today. So new for 2015 is our participant homework. So in order to maximize your learning from this webinar and apply the knowledge, skill, and information to your job, we urge you to follow these 2 simple steps. First is reflect upon the 3 key takeaways provided by Kevin today, and if any are not realistic or relevant to you, then write down 3 key takeaways that are realistic or relevant to you or your municipality's objectives. Then second step is to rewrite the 3 key takeaways into action statements and add specific tasks and completion dates into your calendar as a reminder for completing your takeaways. For additional resources on a broad range of topics, please visit MFOA's virtual library. The library is your one-stop shop for policies, RFPs, guides, legislations, and regulations from across the province. Visit www.mfoa.on.ca/library today. Thank you for now. Bye.